Guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is insertion sort list. So in this question, we are given the head of a singly linked list, and we have to sort the list using insertion sort and return the sorted list head. And this is the algorithm to perform insertion sort. So in insertion sort, you pick each element and compare it with all its elements to its left and insert it at its original position. So you repeat the process for all the elements until the end, until no more elements are needed to be sorted. And finally, once you reach the end, every element will be placed inside its original position and we get the sorted list. So here now again it will check for 1. It will check where its original position is. Its original position is in the beginning because all these elements are in that. And now it will pick 8. It is greater than all the elements, so it will stay. Now it is 7. It will move to its left and it will be placed there. 2 will be checked with all its previous elements and it will go and be placed here, and similarly for 4, and finally you get the sorted array. And this is a implementation for the linked list. You have to repeat the same steps. So let's take an example and see how we can do this. So this is the original list given to us. I create a dummy node and assign it with the least possible value, that is minus 2 power 31 minus 1. So this is the dummy node. We create this dummy node because we can use this to return the dummy.next as the output, because we don't want to move the original head, which can be used as a pointer for the iterations until it reaches the end. And head is here. So I create another node called current, which will iterate from starting till the last node until it reaches null. So until current reaches null, we keep on moving forward. Now we have to compare with its previous nodes to the left, right, according to the algorithm. So this is the I loop. And the inner loop j will be pointing to the beginning. So beginning is dummy, right? So I create another node here, previous, which is j, and this is I. I will keep on until we reach the end. And in each iteration, we have to pick all the elements from, suppose if I is here, if current is here, it will check from j until here. So here, as you can see, I created the dummy node, which is minus 2 power 31 minus 1, and here 4 is present. To its left, there is nothing, so we keep moving forward. Now we are at 2. We compare left position. We have to swap these two, right? So 2 will be swapped and 4 will be swapped, and this connection will be made. Now we pick 1. We compare with its previous values. 1 will fit somewhere here. So fit 1 there, and 4 will be connected to this. And 3 will be compared with the rest of the elements, and 3 will fit somewhere here, right? So move that element there. And this is dummy, like I said. And now we can return dummy.next, which is this node. So if we return dummy.next, you get the output 1, 2, 3, 4, which is the expected output here. Now let's take a look at the code. Then we'll take this example and debug the code, and also similarly do a dry run and see how the connections are being formed. Here, as you can see, I created the dummy node and assigned the value -1 to it. You can assign integer.min value. It won't matter because we are returning dummy.next, and I place a current node to where head is pointing. So current is pointing here. So this will iterate until it is equal to null, until current reaches the end. We run a while loop. Now this is the dummy node which we created, -1, which is initially not pointing to anything. So I create a previous variable here, which will be our j pointer, so that we can act as a reference. This is initially having null as a reference. So in the first iteration, there is nothing to compare current and previous. So here we are checking if previous.next is not equal to null. Previous.next is equal to null initially, right? So we skip our iteration and there is no need to move our previous pointer forward. And here I will check previous.next value with the current node's value for the comparison. Like here in this case, this comparison should be, so this is the previous pointer's value, and this is the current pointer's value. This is the current pointer's value and this is the previous pointer's values. So that is the check we are doing here. If this is true, only then we move the previous pointer forward. Else we create a next node which is pointing to the next node as current, so that it acts as a reference to where current should move next. And current's next pointer, which is this pointer, will be removed and it will be added to where previous.next is pointing. So this is the first step and this is the second step. And next we have to check previous.next will point to where current is pointing. So this is the third step. So this is the connections we are making. And finally, in the next iteration, current will move to where next is pointing. So current will move to, and finally, once current reaches the end, we have a sorted list, which is connected to the dummy node here. So this dummy node will be connected to this. So we return dummy.next. So from here our output will start. So we return this as the head of the dummy node, dummy.next. Now let's debug the code using this same example and see how we are getting the output. So here we have our head initially as the first example, and dummy node is -1, which we created here, which got initialized. Current is pointing at the head, so current will also have the same as head. Now previous will point to dummy, so previous node will be created and it will be assigned with the same values as dummy. So here, as you can see, previous has been assigned. And now we have to check if previous.next is not equal to null. Previous.next, there is nothing, so it is equal to null. So this condition fails and it will skip because this is the first element. So it got skipped. Now next is equal to current.next. Current.next will start from 213. So next is equal to 213. So next is equal to 213. So this is next. And this is the dummy node. And this is also previous. And current is pointing here at the head. And this is the initial head given to us. Now current.next is equal to previous.next. Previous.next is equal to null. So current.next is equal to null. So as you can see, current becomes 4 because current.next will be removed. So this connection is removed and it will point to null. So current.next is pointing to null. So here, as you can see, current is 4 and head is also 4. And previous.next is equal to current. Previous.next will point to 4 now. So previous.next is pointing to null now, but here it will connect to 4. So this will become -1, 4. So as you can see, -1, dummy will also be connected to the same. These two nodes are connected by a single node. Whatever nodes are pointing to this will also be connected to that. As previous.next pointed to current, this node was set up, and dummy is also pointing to this node, right? So that will also have the same link. Now current is equal to next. So we may have to move this current pointer to next. So current moves forward. So as you can see, current moves forward. Current has the values 2, 1 and 3. Current has the values 2, 1 and 3 here. Head is still here because this connection got removed. And now in the next iteration, current is not equal to null. We move forward. Previous is equal to dummy. So dummy has -1, 4. So previous is also assigned -1, 4. So here, as you can see, previous is also -1, 4. Now we check if previous.next is not equal to null. Previous.next is pointing at 4. It is not equal to null. So it will take that value. It will check current.val. Current.val is the value pointing at 2. We check this condition. This condition fails. So this while loop will be skipped. That while loop is skipped. Now next will go to the next pointer. So move the next pointer to current.next. Current.next is this node. So next will move here. Current.next is equal to previous.next. Current.next is this pointer, so remove it. And previous.next is pointing to 4, so set up that connection. Next is 1, 3. Current.next is equal to previous.next. We did current.next is pointing to previous.next. So this will change from 214 to 24. So as you can see, 24, which is here, 24. And now previous.next is equal to current. Previous.next is pointing at 4. So this is the previous.4, right? So remove that and it will point to where current is pointing. So this connection will be made. So now previous will have -1, 2, 4. So -1, 2, 4, which is, you can start here -1, 2 and 2 is connected to 4. So that is matching. Now current will move to where next is pointing. Current will move forward. So current is pointing here. And in the next iteration, current is not equal to null. Yes, it is 1. So move forward. Previous is equal to dummy. Dummy is -1, 2, 3. So previous is also -1, 2, 3. To create a new node, previous will be assigned the same, -1, 2, 4. And now we check previous.next, which is equal to 2. Previous.next is 2. So take that element and take the current element. Current element is 1. Check if this condition is satisfied. No. So it won't enter the while loop. And now next is pointing to current.next. Next will go forward. So next only has 3 now. So here next only has 3. And now current.next is equal to previous.next. Current.next is this pointer, right? So remove that. It will point to previous.next. Previous.next is pointing to 2. So this 1 will point to 2 now. So current is now 1, 2 and 4. And now previous.next is this pointer, right? So remove that and point into where current is pointing. Current is pointing at 1, so this connection will be made. Previous.next is pointing to current. Now current will move to where next is pointing, so current will move forward. And in the next iteration, current is not equal to null, it is 3. Previous will be assigned to dummy, -1, 1, 2, 4. So previous will also get the same values, -1, 1, 2, 4. And previous is equal to previous.next. Now we have to check the value at previous.next. Previous.next is equal to 1. Current value is equal to 3. Since this condition is satisfied, we move previous to previous.next. So previous is here, it will be removed and it will point to where previous.next is pointing. And this is a while loop, right? So we have to check this condition again. Previous.next is 2. So take that value. And current is still 3. This condition is still passing. So move previous again. So here as you can see, it will move once. Again it will go inside. Now again previous will move to previous.next. So previous will move here. Now check again previous.next, which is 4. So we can stop this and it will come out of the while loop. Now we have to move the pointers where next is equal to current.next. Current.next is equal to null. So next is pointing to null. Now current.next is this pointer, so remove that. So current.next will point to previous.next. Previous is here. Previous.next is this connection. It is pointing to 4. This will also point to previous.next. So this connection is also made. And previous.next will point to current. Previous.next is this. So remove that connection. It will move to current. Current is here. So move that connection. And current will point to where next is pointing. Current will move to null. Since current is equal to null, this while loop will return false and we come out of the while loop. So current is equal to null. This condition fails and we come out and we return dummy.next. So let's form the output. So this is dummy, right? So first dummy will come. Dummy is pointing to 1, which is this connection. 1 is pointing to 2, which is this connection. 2 is pointing to 3, which is this connection. And 3 is pointing to 4, which is this connection. And 4 is pointing to null. So that is the end. Now this is dummy, right? We are returning dummy.next. Dummy.next is this. Do another step here. You can move head back to dummy.next. So head is equal to dummy.next. And then you can also return head. Else directly you can return dummy.next. Dummy.next is this. So all the connections from here will be returned as the output. So this is our output. 1, 2, 3, 4, which is sorted using insertion sort. So here as you can see, this also works. Head is equal to dummy.next. And here you can see we're getting the output 1, 2, 3, 4, which is matching here. So the time complexity of this approach is O of n square, which is the worst case runtime for insertion sort. Because imagine a case where a linked list which is sorted in decreasing order, you have to compare all the elements with every element, which will take O of n square time. And the space complexity is O of 1 because we are not creating a new linked list. We are just changing the pointers between them. That's it guys. Thank you for watching and I'll see you in the next video.